Hi there, this is Dr. Everybody with Project 10. Project 10, we have a card game. It's very similar to a lab where you played the game of war. This project is time consuming. It's time consuming because there are a lot of functions for you to do, and it takes quite a bit of work to get all the details right. One of the confusing things the first time students look at a project like this is they think that they have to write the code to play the artificial intelligence to play the game. No, that's not what you're doing. You're writing code to check the rules. So the user is actually playing the game. You just make sure that they are not allowed to make a move that's not allowed in the game. So in terms of programming, though, this is really about taking lists of cards, or actually lists of cards, and manipulate them. So this is really just another project on lists, but the items that we're manipulating are cards out of our card class. So it's an exercise in using classes, but it's really yet another project using lists. So if you think of it that way, maybe that will help it look familiar to you. The other thing that's a little unusual in this project, or something that you need to think about, is that I mentioned we're checking rules. Well, the way we are requiring you to handle the checking of rules is to raise exceptions. And so we have a runtime error exception that we catch in the main part of the program. So every time you find a violation of the rules, you just raise an exception. And once you get a feeling for doing that, you'll see that it makes your life really easy from a programming standpoint. You got a problem, just raise an exception. Right? They tried to do something that's not allowed, raise an exception. And with that exception, you put in a string that describes what it is. You can only put an ace there, or you can, the cards have to be the same suit but different by one, whatever the rule is. So the basic idea, you have an if statement. If the user tried to do this, raise an exception. And so you raise you have these checks that would raise exceptions, and then if you don't raise any of those exceptions, then you know that the user has followed the rules, and then you can take whatever action that needs to be. And I'm going to go through a function where there's the line. There's like one line to do the action, and the rest of the lines are all just checking. Check this, raise an exception. Check this, raise an exception. And so you want to think about it in those terms. So this is really a project of manipulating lists, and we're manipulating lists of cards. And then we're doing all of our error checking with raising of exceptions. Think about doing and testing these functions one at a time. I'll show you how to do that in this video. A place that you can really get yourself in trouble with is that the second function that you need to do something with is the display, and that's messy. It's not hard, it's messy. It is trying to get the details, get the cards lined up, and in a row, in columns rather than rows, and it's something you can all do given enough time. You could waste all your time just getting it to look pretty. Don't do that. That's not smart strategy in terms of points. Start out, just print the list. And then later on, when you've got the rest of the program going, then you could say, all right, let me sit down and make this pretty. That's a strategy I suggest for you. So with that, let's take a look at the project itself. First thing is it's playing a game of cards. You ought to get familiar with this game. The rules are relatively straightforward, but you got to be familiar with them, and you can play it online. If you try to play the game, which has nothing to do with the project itself, I find that to be a particularly challenging game of solitaire. Okay, so let's take a look at what we give you. Well, one of the things we give you is we give you a project that, we give you all the functions. You're welcome to add more, and I did. But all the functions that you need are there. And then we even give you the driving loop. We figure you've done a bunch of these. We might as well give it to you. And there's a couple of things to notice about this. Okay, we keep looping until we get a cue. And again, all through this code, you'll see these passes because that's what you have to replace. But so all your code's going to go here. And then at the bottom of that, we catch this runtime error, which has an error message, and then we print it. Then we display the game, what's out there, and grab another prompt. All right, and so all your code in here will keep. Every time you find a problem, you'll raise a runtime error. It's got to be spelled that way. We catch it here, and all we do is whatever string you give it, we print that out. Oh, you should have had an ace here. The suits are wrong. Whatever the error message is, we print it out, and then we prompt again. All right, so let's start taking a look at code. I'm going to scroll up here a little bit. The first thing that you need to do, and I'm not going to talk about this today, is you have to do the setup, because nothing happens unless you set it up, and you've got to put all that good stuff right here. Oh, also remember to shuffle your deck. But you might want to wait on shuffling, because one thing that's nice when you're playing around with it is that until you shuffle the deck, the cards are always the same, and that might make testing easier for you. So here you create the cells, the foundations, and the tableaus. That doesn't make any sense until you read about the card game itself. But those are the items that we play with, and you have to you've got to understand them. You've got to set them up. And notice, okay, it's very important that cards are dealt in a particular way. They're dealt in a particular order. This ends up being important because the tests depend upon that. So you want to make sure you get that correct. And there's a test for that. To display the game, right, well, you need to have the cells and the foundations, and this is the messy part. What I would suggest you do is just start with something simple. Just print the cells. It's just a list. Print the foundations. And then down where the tableaus go, just print the tableaus. That's the simplest thing that you can do. And you take it from there. And I meant to put this on my videos project, so let me fix that. That looks better. Now you can see the tableau doesn't look very nice, but it's workable. Might be a little nicer to go, if you would like, for L in tableaus. Print each one. Oops, I got to make sure I quit out of this. There we go. Now you can see with that simple change, now my tableaus are printing. But the problem here is that the tableaus are supposed to be printed down, and they are in fact printed across. Okay, but that works for right now. Right. Later on, you can go through and, all right, how do I print this so it prints down? But now I have something that is usable. The other thing is that by indices 0, 1, 2, and so on, but those are not the real ones that we use. We start at 1, so that's 1, and that's 2, and that's 3, and so on down. Just watch out for that. when you're doing that. Okay, so now I've got this thing. Yeah, I've got the basics done. Get that going. And at this point, you should check that you've dealt the cards in the right order. Okay, do I have them dealt in the right order? And figuring that out, that'll be important. Let's take a look at one of these functions. And what I'm going to do is take a look at this first one. All right, when I move a card to the foundation, right, and I'm going to get rid of the pass there. So when I move the card to the foundation, what do I need to know? Well, it needs to be an empty foundation, and we need to have an ace. That's a valid move. Okay? And what do I do if I have an empty foundation? And how do I handle that? I simply return. Suppose I don't have that. Suppose I have an empty foundation and it's not an ace. Raise an exception. Not only do I raise an exception, but it's my runtime exception. Right? And you get it down. Runtime error, not runtime exception. So let's get that. Let's fix that runtime. I knew that was wrong. Runtime error. And I'll have a message in there. Need ace. That's a stupid message, but it just gives me something to start with right now. What else do I have? Well, when I put something on the foundation, I need things to be the same suit, and rank is +1. They differ in rank. That returns. That's okay. And then the other thing I need to come up with is the not of that. If I don't have that, then I raise runtime error. Say need same suit and rank +1 or something like that. All right. Oops, and that's a string. So let me remember the quotes. And so that's all my cases that I need to check. Now I need to put that into code. So one of the things we suggest is that we have when you have an empty foundation, then have the destination card be none. So empty foundation means destination card equals none. All right. Actually, I'm going to let me back up this a little bit. I'm going to take the case, this one. I'm going to do the raise the runtime error. I want to show you that. So if we have an empty foundation, which means my destination card is none, and the source card dot rank is not equal to 1, that's not an ace, then I want to do this. Okay, so I'll raise that runtime error. All right, so if the destination is none, that means it's empty, and I don't have an ace, then I want to raise a runtime error. if and let's take, now we can take the other situation, destination card, and it is an ace. What do I want to do? I want to return. And in fact, you could check, you actually don't need the second part because you didn't get to this point if it wasn't actually equal to an ace. But there's the two situations, in terms of an empty foundation, which is my destination is none. And now I can look at the other, where I can say, all right, so what does it mean for the suits to be the same? So that means that my destination card suit, and please remember the parentheses, equals the source card suit. And my, let's see, the rank differs by 1. So let's think about that. That means my source card has to have a 1 greater rank than the destination card. So if I look at my source card rank, and I look at my destination card, it's got to be 1 bigger. Right. That would be my good situation, right? Suits are the same, ranks 1 bigger. I'm going to negate that whole thing and say, all right, if I don't have that situation, that's when I raise my runtime error. Okay. +1. Oops, I didn't get it all. There we go. Suit, and rank is +=1. So you can just go through, and every time you find something wrong, and in this case I did it with a not. I decided what was there, and then I said, oh, well, if I don't have that, then I raise a runtime error. And the reality is, at this point, if I haven't done any of these things, all I need to do is return, I've checked all my possibilities, and the only thing left to do is to return, because I must be good at this point. So now I can look at the here it is. We're going to the tableau, to the foundation, and what happens with the with my well, I am going to check. I'm going to perform my check. That will raise an exception and just dump it back to where we catch the exceptions if there's a problem with the source card and the destination card. And notice I've got a little error here because I haven't defined those yet. And how do I actually do the move? Well, what I do is I'm going to append onto my foundation what I popped off of my tableau. So I actually end up, so there's my check, there's my action, and it would be really nice if that's all I had to do, but we are, I haven't defined my source card equals something. I haven't defined my destination card equals something. I need both of those because that's my little warning over here. And I need some other checks in there, like suppose there's nothing in my foundation. So if my foundation is empty, then what do? Then raise an exception. And again, always runtime error exception and some kind of blah 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 that will go in there. Okay, foundation was empty. So I need to have, and I need some other error checks, or I need some other checks in there. And in fact, I ended up, because the whoops, I'm sorry, I should have said I don't have an error if the foundation is empty. I have an error if my Tableau is empty. Oops. Okay, so I got to get that right. So if the Tableau, well, then there's nothing to move, so I've got an error. If my foundation is empty, then what does that mean? I think that means my destination card will be assigned to none, otherwise it will be assigned to whatever card is there. And so you have to look at your list and see what's on the end of your list. And the same thing with the source card. That's coming off the Tableau. What's in my Tableau? What's at the end of my Tableau that's in fact going to be moved? So those are, that's how you go about doing these. So I've made a start on, I may even have completed the valid function move. I have to think about that. I've given you an outline of how to do the Tableau to foundation. And then we can go along and, we can actually now say, oh, okay, so Tableau to foundation. Let's go down here, and how do I know what I'm going Tableau to foundation? Well, there are some instructions here. There they are. Tableau to foundation takes 2 arguments. So now I need to look at my my command, and what am I going to do with my command? Well, I have to split it because I need to split it because I've got 3 items here. So I gotta split it to come up with those. I need to check. Do I have check the arguments? What do I need? Well, I have to have 3 items. The first must be TF. Second and third. Third must be integers, and they can't just be in a certain range, right? I can't have x be -5 and y be 238 because those aren't valid numbers. And guess what? What do I do if there's a problem? We raise runtime error with some kind of a message in there that's appropriate for that. So notice how that goes. We check things. There's a problem. Boom. Just raise a runtime error. Right? And then once I've done that, I can then go call my here it is. I can go call this, and in here someplace, then I can go and call this. And these, by the way, are not the whole Tableau. So this will be something like tabs of some index, because that will be a particular those will be particular foundations. So you need to have some kind of, I'll call it an X in there, and some kind of a Y in there that we get here, and those are probably the X and the Y here are probably related to the X and Y there. Watch out for off by 1. In other words, your lists start counting at 0, but when I specify commands of the game, I start at 1. And so you got to always be, there will always be all these +1s and stuff like that, but you're sending a list in here. And then once you've got this going, notice how I have access to these to the variables that I've created, and so I can actually test these out, and I can send particular arguments to it. I can say, tabs 0, and we're going to foundations 0 or something like that, and I can test things out, and it should work. Let's see, there's an ace at the end, so that's 0, 1, 2, 3. So that's row 4 if we started counting, so we could go there. And once my function is implemented, which I haven't fully implemented it now, I can then test it right there. So and you can go through every time you build a function, you can test it here. You may want to create a card, and we can create a card. I'll call it C equals cards dot how do I create it? Okay, so I've got the card class, and so this is in cards. It's in the cards file, and card, and let's see, we give it, and we look at the init. It takes a rank and a suit, and so let's make it be an ace, and let's have it have a suit of 2. What card is that? All right, that's the ace of diamonds that I just created. And so I can then pass that, I can now use that card, for example, to check and see what's happening with my valid function move. I need to send it a source card and a destination card. I can say C2 is, maybe I could just have that equal none, right? And so I can then test out the code that I have there. So there's a bunch of stuff to get you started. Remember, this is a project that is a list of lists. Good luck.